and deriving some insights from data that has been amassed in our financial sector, meaning our personal financial sector. Okay. So I'm going to go ahead and share my screen, and I am going to um, explain the process from start to finish. So what you see on the screen, hopefully, is a blank Jupyter notebook. Does everyone see that? Is there anyone that does not see it? Hopefully you're all right. Okay, so you might be wondering, why is this blank? Now, let me just explain something here. Jupyter is a development platform that allows you to type in Python code and execute it. So it compiles it and what have you. Jupyter is free. You can download it and install it on your computer and run projects very much like I am in the browser. You'll notice I have a web address up here. Okay. Um, you can also use Google Colab. So Google Colab, hopefully you guys can see that. That is from Google, hence Google Colab, right? And that is another free environment that you can use to code Python notebooks. So tonight I'm going to work in Jupyter. I'm actually running Jupyter and another development environment or server environment, I should say, which is Anaconda. Okay. Now, the purpose of tonight is to not show you how to install all this software. In our boot camp, I go through how you can set up your nodes and your computer and get your software up to snuff. Okay. So tonight is going to be very simple. Any questions thus far? So it's kind of plain. So you're wondering, well, what is this? Well, this is a template. Now our template, I'm going to explain the template from top to bottom, and then I'm going to actually code in the different cells that don't have information in it. Okay, so every project has a background, and tonight's project, as you probably learned from the description of the workshop, is about a financial spreadsheet that has been gathered over a period of a year. Your bank basically allows you to create a budget for your spending habits, right? And at the end of the year, you might be wondering, well, why did we have, why did we spend more than we planned on? And that's a common problem that people have. Again, businesses have that same problem, but I chose something a little simpler in case we had folks come in that are very new to this and maybe something that resonates with them. So the first thing is we have a project background. So what I'm going to do in this cell is I'm going to fill in my project background, and I'm just going to paste this code in only because of time. So the project background is important. So in this case, a financial advisor has been asked to give insight to a family on their finances, and using the record data that came from the bank, a spreadsheet that we downloaded of all of 2020's activities, we're going to perform descriptive analytics to determine what spending occurred by category. Now, you might be wondering what descriptive analytics is. Well, descriptive analytics looks at data that was gathered historically and attempts to make insight about that data. Okay, does that make sense? And if anyone has questions, don't hesitate to ask. And perhaps, Yulia, if you see a chat, a post in the chat, just let me know, and we will
Sure.
answer those questions. Okay. All right, so that's our project background. Now, it's important to understand the problem domain. So the problem domain basically tells us that we have to get the data from somewhere. Now, I just explained to you that we're getting bank record data. Obviously, the bank is going to let you have your data because it's yours, right? In the real world, if you were going to access data, you would have to make sure you have permission to get that data. In this case, it's data that the client has given us, and we have access to it. All right. So our project goals. And again, I'm just going to double click, paste this in. By the way, I'm pasting code in rather than typing it in tonight, only because, well, we had a little mishap, and we slipped on ice, and we're not typing very well. So that's, again, to facilitate the workshop. So the project goals are to understand what columns we have in our data, what data values are present, and to detect the patterns and the trends in the data, and also to determine if there's anything unusual in a specific month. Okay, now I see I have a typo here, so let me fix that. All right. these things happen, right? Okay. All right. So the problem domain is a financial one, right? So that's very important to understand. The second thing is we want to have a set of questions that we plan on asking. All right. So here are some questions. Now, let me put these in order because we want to answer them in order. When we derive insights from our code, we want to make sure that all questions that were asked have been answered. Okay. So we want to know in general, kind of like a hypothesis, how much of the budget is allocated to each category? Is there any category that stands out that's unusual or low or high? And lastly, does spending change throughout the year? Now, why is this important? Well, from a budgetary point of view, being able to assess what happened last year, if things have changed, let's say this year, jobs are different, spending habits are different, we need to plan accordingly. That's why we would want to gain insight from last year's financial picture. Okay, so this is a financial driven exercise. Okay, now libraries. In Python, you're going to need to be able to compile code that accomplishes your goals. So there's going to be different libraries that you need to import into the Jupyter Notebook so that Python can do what we need it to do. So I'm going to go ahead and paste this in and explain what each one of these is. Okay, can everyone see my screen okay? Before I get into the nitty gritty, I want to make sure that no one's having trouble seeing. All right. Hopefully everyone's good. Okay, so let's go one library at a time. Python has something called pandas, and if you're going to use pandas or pandas, some people say one or the other, you need to understand that it's used for the basic data analytics that you're going to do and the data manipulation that you're going to do. Everyone uses pandas, all right? Everyone uses NumPy. NumPy is the mathematical piece. So you will see very commonly in almost every Python notebook that you do, you're going to see the import of these two libraries because there's usually going to be some calculation and there's usually going to be some type of manipulation of your data. Remember, the data comes in raw and we're going to have to tweak it to make it possible to analyze it. Another very common thing that we need to do is if there's a date related column in your data, you need to manipulate it and treat it like a date. And that's what this line of code highlighted here is using the date time library. All right. The other thing is creating graphs. So Matplotlib is another library that you use for creating graphs. PyPlot works with Matplotlib to make cool graphs. So Matplotlib makes some really nice graphs, but if you want to kick it up a notch, which I figured I would do tonight, I am adding an additional library for my graphs to enhance them, to make them look better. You might have additional color palettes. You might have additional things that you can do with your graphs. So that's the libraries. So your imports always go up at the top of your document. Your document, by the way, executes from top down. So you'll see that this cell here is green because I've typed the code and I've clicked run, and now it's gone to the next cell. So in a notebook, you've got a variety of cells. So the next column, or the next row, I should say, is data importation or data importing. All right. This doesn't get executed. It just gets hopped over. It's not compilable code. It's actually markdown. Okay. So in my notebook folder on my computer, I have a file from Excel. It's a CSV, and in that file is the family budget. So this is the file that I've downloaded from the bank, and I plan on reading it in or importing it into my Jupyter Notebook. Okay, now very important for those of you who are programmers out there, anytime you have something on the right of the equal sign, you're assigning that to what's on the left of the equal sign. All right, so I have a data frame or DF variable, and I'm assigning the data that I'm reading in to that variable called DF. Okay, so I'm going to run this, and voila, nothing happens. It doesn't say anything good or bad happened. I will tell you, if there was an error, it would throw that error right on the screen. Since we don't have an error, that's called all good. Okay. All right. So now we've read the data in. Now you might be wondering, well, what does the data look like? Okay. So one thing I can do is I can insert a cell here to make sure that my data did in fact come in. All right. For the sake of time, what I'm going to do is I'm actually going to ask how many rows and how many columns are in my data frame. And I'm going to do that in my data exploration cell. So I have a comment here. How many rows, how many columns are in the data frame? I'm going to run this and it tells me there's 361 columns. I'm sorry, 361 rows and 5 columns. Okay. Now at this point, I still don't see the data. That's okay. I'm going to show you the data in a second. Okay. All right. The second thing I'm going to do is I'm going to ask how many elements are in my data set. So I need to insert a cell beneath this one because I'm not into data preprocessing yet. I need to expand my template. All right. And the way you do that is you have this cell highlighted and you're simply going to do insert cell below. All right, now I have a cell where I can type in my code. I want to know how many elements are in the data frame. Now, what this is going to do is this is going to multiply the rows times the columns. All right, so sort of like a matrix. How big is my matrix? Well, there it is. It's 1805. So that's how many elements, how many cells in the spreadsheet I have. Okay. All right, so I still have some more data exploration that I need to do. Now, data exploration is basically getting a gist of what your data set's about. Okay, remember, I've downloaded it from my bank and I really haven't looked at the spreadsheet. I'm doing some investigation to see what is, the basic essence of the data set, to see how big it is and things like that. These are pure descriptives, nothing very fancy. All right, the next thing I'm going to ask is how many of my rows are in my data frame. Now, I already know that answer. Why? Well, it's up here. But another way that I can ask how many rows is to look at the length of the data frame. So this is just another way of doing the same thing. Now, obviously, I want to see some congruence between these two values, right? If I had 361 when I asked for the shape, I should have 361 when I ask for the length of my data frame. Okay, that's just to show you that there's two ways of doing things. If you just wanted the length, and not the width, that's how you would do that. All right, so I'm going to insert another cell. Let's say I wanted to just know how many columns are in there. Again, I'm not typing code tonight because of my hand. I slipped and fell, but so we're just copying and pasting here. But if I wanted to see how many columns, I would do the same thing. Now, this shows me how many columns, but it does it by concatenating the set of based on index of each column. So I see that I've got 1, 2, 3, 4, 5 columns, right? That matches what we have up here. So that's good. And it tells me the title or the header, the title of, each of the columns at the top. So that gives me kind of an idea of what's in this data set. I've got the transaction ID, description, category, month, and amount. So I have a general idea as to what this data may look like. I still don't have a definitive as to whether or not the data is any good. I don't have a definitive as to whether or not I can use this data. Again, we're investigating at this point. Now, the next question is, well, what kind of data types do I have? Because all programmers need to know these things. If I'm going to manipulate my data in a specific way, so for example, if I'm going to treat the month column like a real month, it better have a data type that recognizes it as a date. Okay, so I'm going to identify my data types and voila, here we go. So we've got an object for the first 4 and a float 64 for the amount. So an object is basically an object that is recognized by Python as having maybe a container of data. So the category is basically going to be some data that I could treat like an array. I could actually tell it to manipulate that object specific to my needs. Right now, I'm concerned with the month, and I'm concerned with the fact that I have a float 64. Now, amounts typically are going to be in dollars and cents. So the fact that I have a float is good because I know that the cents values will be there. All right. If I had an integer for the amount, I would not have the cents values. And as you all know, you can add up the cents, of transactions. And if you have a lot of them, that can add up to some dough, right? So the fact that I have a float is important to me, and I'm glad that it came in that way. In a little bit, I'm going to show you how to change it, but that's just something that this tells me that I'm halfway there. All right. The next thing I might want to ask is some summary statistics about my data. And summary statistics are going to be basic, mean, mode, and things of that nature. So let me go ahead and run this cell. All right. It didn't really tell me the mean and the mode, but it gave me some basic information. And it seems like it's the same as what's up here. Yeah, you're right. So this summary statistics is somewhat general. Doesn't give me a lot of information. It tells me how much memory I'm using, the data type. It also tells me that I don't have any blank columns, which is a good thing. So that tells me that I've got a solid data set without any blank columns, but it doesn't tell me if the data is garbage. See, that's the sad part about the data analytics individual. They get excited. They say, oh, I got a full data set, only to find out that the data is GIGO, right? It's garbage. So but it's still looking good. I'm an optimist. So I'm gonna keep my fingers crossed. All right, another way of determining, whoops, wrong cell here. Let me get up here. Another way, see, I told you I was injured. I can't even click. Look at this. Okay. Another way of determining if you have missing values is to use the sum function against the is null function. And what this does is this quantifies whether or not you have any. So even though this said non-null for each one, this gives me actual numbers. I have 0 values that are null for those 5 columns. Now, I may have NAs in there, however, and NA is something that people typically put in as not applicable. Well, that's going to be hard to calculate, right? This is a financial, problem. So I need to now determine, do I have any NA values or, N/A, which again is a problem that we could still deal with, but we need to know at this point. And it says false. So we're good. No NA values. So we have a solid data set. Hopefully they're reliable numbers and so on and so forth. Now, let's say we had found out that we had missing values, okay? It's outside the scope of this workshop, but there's ways of dealing with those missing values. In some cases, you might take the mean or the average for a given column, and you might say, let's impute those values. It's a process called imputation. Let's impute them and use an average because it's at least reasonable. And given the number of values that are missing and or empty, it's a reasonable approach to it. So you don't take a one-size-fits-all approach. Since we don't have any holes in our data, we don't need to worry about that. But if you're wondering, what do you do with those? The other thing to remember is, let's say we determined that 5 records out of millions of records had null values. Well, I could delete those 5 records and more than likely not experience too much data loss. So it wouldn't compromise my ability to analyze my data. But if I had, let's say, 5 records in a 10 record set, that's 50% data loss, right? So you have to always know, well, how much data am I working with? And if I do delete some records, is it going to create too high of a data loss? Again, kind of outside the scope of our discussion, but I figured I would mention it because you might be wondering. All right, so the next thing we're going to do is we're going to go into data preprocessing. Now, data preprocessing is used to take our data and transform it into something that we can use for the purpose of analysis. All right, so the first thing we're going to do is the descriptive statistics, and this is where we get the mean and the central tendency and so on and so forth. Now, as you may have guessed, this is only going to work on numeric values. So our amount column is the only column that has the float 64. We talked about that earlier. So that is going to give us our min, which is 0, which is not a good number, by the way. I'll explain that in a second. Our max is 1750. Okay, that kind of makes sense, but this 0 value has me troubled because I don't know about you folks, but when I pay bills, they're not 0. They're usually more than 0, okay? So this has me curious, right? 1750, that represents some of my bills. I know but the zero got, that's something that's a little odd for me. 50% of the records are at 100, 75%, 150. Okay, that seems reasonable, but the zeros got me, curious. So we're going to investigate that in a second. Now, at this point, I want to see a sample of my data. After all that hard work, let's at least see, a random 10 records from my data. So here we have random set of 10 records. Now, in looking at this, I can see some interesting things. I've got this transaction ID, which is a nasty looking number, right? Probably not worth analyzing. So I'm going to probably get rid of that. That really doesn't give me any benefits from my analysis. So in my mind, or I could be writing down notes as the data analyst, I'm going to delete that column eventually. My descriptions look reasonable. My category looks reasonable. Month looks reasonable, and the amounts look reasonable. Everything looks pretty much, again, this is a random sample of 10 records, but things look reasonable. But, I'm definitely going to get rid of that transaction ID. All right, so I'm going to insert a cell below. And the next thing I want to do, which in looking at my data, I notice that it's not sorted by month. And that's a little frustrating for me because I don't know. I don't see any. I see maybe one January in here, but I don't see any February. Let's sort it by month and let's check that out. Now, you'll notice here that I am sorting. I'm using the sort values command against the month column. All right, I'm calling that function against my data frame and assigning it to sort by month, all right, which is a variable. So I'm going to run this, and sure enough, now the Januaries are up here. And since we're only seeing so many of our records, right, we've got September at the bottom, and probably beneath that is going to be our December and so on and so forth. So I pretty much have things sorted. I like what I see. It still looks normal. So I'm going to keep going. Okay. Now I still have some pre-processing to do. As I mentioned, we have a few goals. So I'm going to insert some cells just to get them in here so that I can facilitate my planned pre-processing here. All right. Now, I may have some outliers. Now, we know that the zeros were outliers, right? But let's say I want to really check and see, do I have some outliers in the amount column? I already know zeros are there, so let's check that out. And sure enough, in going through this, I'm looking. Look at this. So we know that we don't have any zero bills, right? But I've got seven records that are zero for the amount. And that's got me wondering, how the heck did that happen? When I do my budget with my bank, well, I usually categorize things, and 2020 was a very interesting year. So maybe something happened. This point, all I know is that there are seven that appear to have, zero, assigned to that category. And it just doesn't seem right. So again, I'm going to write down notes and say, okay, I need to look at that. Okay. Again, this is one of the goals for pre-processing. All right, let's look at the next one. The next one is going to be frequencies. So let's think about categories and frequencies. Now, mind you, our category fields, which if you remember up here, are things like housing, personal care, loans, and so on and so forth. So let's say we want to see what's the percentage per category, to see if that's reasonable. Okay, so this command right here allows us to get value counts for a given field or given column, also called a feature, and print it out to the screen. All right, so in looking at this, and again, your own finances, right? Housing is 23%. Well, that's pretty reasonable. If you pay a monthly mortgage or monthly rent, housing is going to be a considerable amount of your budget. Personal care, though, is 19%. And that's got me a little perplexed. Now, if you're like, your family's like mine, some people may share the finance, with a friend, a spouse, a sibling, what have you. And everyone categorizes things a little bit differently. So I'm looking at this and saying, personal care. I don't remember getting pampered much in 2020. So I'm gonna write that down as being suspect, needing to be looked into. We have an other category which is very small in size, so I'm not too concerned about that. We've got food, entertainment, our pets, transportation, and loans. So loans is number 3, and that's something that we have a goal to pay those loans down. And that number, for personal reasons, you might say that's a little large. We may want to shave that back a little bit. So now we have some understanding as to where the stack is. So the top 3 are jumping out at me here. Transportation, we really can't do much about. Let's say we take public transportation and we have to go to our job. There's really not much wiggle room, but we see that there are some goals that we can address down the road as we start analyzing. All right, the next thing I'm going to do is I'm going to investigate that personal care category because that's got me bothered, right? So I want to filter my data frame so that I have all the personal care records for that category. So personal care is a category, and I view it in a cross tab to see how many of them there are. Okay, so sure enough, personal care appears to be the dry cleaning, the hair and nails, the health club, the holiday club, medical, and organization dues or fees. So the person that helped me with the budget last year kind of lumped everything up into personal care. Okay, so that's what's making it bloated up here. It's 19%, we'll say almost 20% of our expenses, right? Well, there's a reason for that because all of these descriptions are under that umbrella called personal care. Now, so that's, some learning here. Second thing is we look at, okay, we have 12 records for dry cleaning. Okay, once a month we take dry cleaning. That makes sense. All right, do we see anything unusual with hair and nails? Well, once a month we go get our hair done, right? Health club. Well, we have a monthly subscription to the health club. It's in the house because of COVID, but that looks reasonable. The holiday club, we save money. Every month we have $100 go to the holiday club. So that's normal. Medical. Well, once a month we go to the doctor, maybe, but that looks interesting. I don't remember going to the doctor once a month and paying 50 bucks. So that's a little odd. We're going to make a note of that. That looks strange to have 12 transactions towards medical. Given COVID, a lot of folks weren't going to the doctor. They were doing telemedicine, right? So that looks a little interesting to me. So that I'm going to look at to see what's going on there. All right. So the next thing I'm going to do is I'm going to analyze frequencies for description. Okay, we did description frequency or category descriptions before, frequencies rather, sorry about that. So now I'm going to look at my frequencies for description. So here we're looking at medical is 6%, credit card, Visa 3%, personal 3%, gas 3%. There's a lot in common here. You can kind of see there's a lot that sort of share the same value. And then we have some, tails here. We've got other very small, and we've got, it seems like our Visa card's a little high relative to everything else. And then we've got that medical, which is still bothering me. Who went to the doctor and why, right? Makes sense. So we're going to still investigate. We're still doing pre-processing here. So let's insert some more cells here. All right. And here we go. Now, as I'm doing this, if you have questions and you want to ask a question, feel free to do that. Or we could take questions at the end. And I'm sure, Yulia, you'll let me know if there are any questions that are pending that I don't see. All right, so we've already talked about the fact that medical is suspect. We don't understand. We don't remember going to the doctor 12 times. This is kind of a mystery to us. So we've decided to focus on medical, and we're going to filter out everything but medical and do a cross tabulation so that we can see how many of the medical transactions we can see. Aha, there's the mystery. So medical is not just the humans, it's also the pets. And if you're like me, I have a dog that goes for therapy, and the dog goes for therapy to get his his physical therapy because he had an injury. So medical, half of those things went to the humans and half went to the pets. So this actually makes sense, between the medicine and, you know, all those things. This makes total sense. And now that I'm thinking about it, well, you know, we did do telemedicine. That does cost money. So this kind of seems reasonable now that we've investigated it further. Um, and one of the points of learning is when you meld things into an umbrella category, right? And you start analyzing that data. If you don't understand the nature of what's in that category, you might make assumptions and you know, make decisions based on those assumptions. So you really want to understand your data at a very granular level. All right, let's look at the next one. Now, we had talked about those amounts that were zero. And, you know, it's one of those things where I just don't pay bills that are zero. It's one of those things. I haven't been that lucky. So we're going to investigate, what is that about? Aha. So we did a filter on our data frame. We assigned it to a separate data frame. And the reason we're doing that is because we don't want to change the original DF data frame. So I created another data frame called DF underscore filters, and that's going to show me my sporting events at the amount of 0. So because sporting events were canceled during 2020, those transactions we had planned on paying for, you know, a sporting subscription as entertainment, and that kind of went out the window because of COVID. So we wound up paying nothing for those. So those records really aren't needed because they're zeros. They really don't help our analysis. So we're planning on getting rid of those as part of our cleanup in a few minutes. All right, so now we're going to look at the first 5 records of our data frame. Now, mind you, this data frame, DF underscore filtered, is not the same as the data frame that we started with. All right. If I run this, you'll see that we have those transactions that we saw earlier when I first started. So the point is, if you do not want to impact your original data frame, you have to assign a copy to another data frame variable so that you can manipulate it. So this data frame that you see right here that shows us our sporting events is not the same as this one. Okay, they are totally different. So when I chose to print out DF filtered, I could jump down here and say, hey, let me see that again. And there it is. Okay, 2 different data frames. One is a copy of the other. Hopefully that makes sense. So I've added a row here, or sorry, a cell here. If I wanted to delete it, I could do that just by clicking on Edit and Delete, because I actually don't need that at this point. All right, I do need one more cell, however, for our pre-processing, and that cell is going to give me some histograms. Now, the histogram that I'm going to put in here before I actually execute it, the histogram, you'll notice, is being assigned to a variable called hist, because you're taking the contents of your data frame, throwing it into a histogram, which, by the way, is like a bar chart. You want to assign it to a variable for that purpose. And that's what I've done here. I'm not going to get into bins because that's a separate topic, but basically the number of bins determines how your data is going to get grouped. Okay, so every bin has a size. I'm going for 10 bins, and I'm going to show you what that looks like. Remember that the only value that is quantifiable is amount. So the amounts are going to get clustered into bins. So you remember I had a minimum of 0 and a max of 1750. It's going to break up that range into 10 groups. Okay, and my figure size is going to be a 10 by 10 so we can see it. So I'm going to go ahead and run that. And voila, I get a little chart here. Now, does this tell me a lot? Not really. It's okay. We can see that the majority of our, we've got a huge outlier here. A lot of our transactions are small values, right? You can see here that, we start at 0, we go to about 175 or so, right? And the majority of those transactions are relatively small. And if that's what you expected, then this is representative of what you know to be true about your spending. All right. On the other end, we have very small amount of 1750. So that's at the other side. And if you had some infrequent, higher priced transactions, you would want to see this. Now, let's say you didn't have a lot of high transactions, but you saw a huge bar on this side. Now you'd be wondering, what is that? And where did that come from? Okay. But based on what I know about my spending habits, this is representative of the norm for last year. Okay, so again, it doesn't tell us a lot. Remember, I told you that histograms are not as nice looking as plotlies. Plotlies are going to be snazzy graphs. So we're going to get to the snazzy graph in a second. All right, so this is basically our exploration of the data. I think I before said pre-processing. This has been our exploration. Okay. So you can see here, I'm just scrolling back. This is pre-processing mislabeled. So I apologize. This should actually be the exploration part. Okay. So let me just jump down here and continue on. This is what happens when you injure yourself. Okay. So I'm going to add actually 5 cells here. And the reason we're adding 5 cells is we need to handle some changes in our data. First thing on my list, who remembers? Transaction ID. That was actually a GUID that I created, and I don't want to ever see it again. Okay, so first thing I want to do is I want to drop that column called transaction ID, right? That's the first thing I want to do. Now, very important. I'm going to drop the transaction ID. It is the first column in my data set, and I'm going to drop it in place, meaning that my data frame is going to change. All right, let me show you what I mean. As a matter of fact, let me, for representative purposes here, remember our data frame, right? Our data frame looks kind of like this. So I'm going to drop transaction ID because I don't like it. It's kind of in my way. It's getting on my nerves. And I'm also going to make sure that my month is changed as well. I want to make sure that that is renamed because you'll notice here that this is not really a month. This is the date, right? So I'm going to change the name of that column to date. So from month to date, again, in place equals true because I want to change my original data frame. Okay, so let's go ahead and execute that. And now let's run this again, go to the cell above it, and voila. I've dropped the transaction ID because it didn't have any value, and I've changed the column name to date. That makes more sense. All right, makes more sense. So when you do in place equals true, you're changing the original data frame. All right, next thing I want to do is amount, we already know is a float, okay? Because we checked that earlier, but let's say it wasn't, and I wanted to force that cast into a float. Because in order to do that, remember, I want my decimal values, right? So let's say it was an integer. Sometimes when you import data, it comes in ways that you didn't expect. And even though the data in the spreadsheet in Excel looked like it had decimals, sometimes when you import it, it comes in strange. And that's just the way it comes in. If I wanted to force it to be a float, I could do that. Now, notice I'm actually changing this data frame. I'm not making a copy. I'm saying assign the type of float to the column called amount to the data frame column amount. So if I do that, I basically have changed it to what it already is, which was just a, just a demonstration there. All right. One thing I do want is to make sure that it is 2 decimal places. So you'll notice we only have 1 decimal place here, and that's a little annoying, especially if we, let's say, have 75 or some kind of, 2 character, two values, right? So here I can change the amount column to 2 decimal places to get that granularity that I'm looking for. And then if I run this again, there I have my 2 places. Okay. In this particular example, you don't see any 75s or anything like that, but I know for a fact there are some numbers that are not even, based on just my knowledge of the transactions. All right.
Hey, Cynthia, I have a
Yes,
question. Um,
absolutely.
by removing the transaction GUID value, are you able to still have a key index value with the numbers on the far left?
Yes, so I'm glad you asked that. So these numbers here are recognized by Python, all right, the Jupyter Notebook. But there is something called iloc, and iloc is the system's way of looking at it as an array. So each index is inherent to that data frame. So this is just an indicator based on the notebook, but I could actually call it and put that index into a separate column to get that unique value. All right. So absolutely, if you wanted to create like a key or something of that nature, you could definitely do that. What's commonly done is you'll throw an iloc against each row and say, given the position in the row, assign it that key instead of that nasty GUID. All right. So what you see here is not part of the data, these numbers here. Okay. So literally what you would get is to the left or to the, to the right, you would get your iloc values. Okay, so this is actually an array, so it bases it 0. Does that
Uh,
make sense?
I understand that, but isn't the only thing unique about each row was the GUID, right?
That's
That's all I'm
correct.
saying.
That's
Is
correct.
by
Yes.
removing that, there's no unique value to reference unless you use the numbered column or each.
That's
Uh,
correct. That's correct. And here's the thing though, given the nature of the data analysis that we would do, there is still implied in the organization of that matrix a unique value. You just don't see it. So it's inherent to position. It's a set, and that set is not changed. Does that make sense? So for example, let's say I sorted this by date, and then I went and I ran the iloc and I said, give me a new column, take the iloc where we're at right now and assign a unique number based on location in the row, right? So this would be 1, 2, 3, 4. It would do that and give me that unique value again. And then I could treat that like a key if I needed to. Does that make
Understood.
sense? Yeah.
Yep.
And I know
But
exactly what you're saying there. The other thing you have to remember too is if you plan on merging this with another data set, which is commonly done, you need a way to do a one-to-many or a one-to-one or what have you for the merge purpose. Okay. So, and I think that's what you're alluding to is treating it as a unique, maybe as a primary key and connecting it to a foreign key in another data set. Am I right on that?
Absolutely.
Yep.
Thank you.
Yep. Yep. So thank you so much. That's an awesome question.
you've lost the original row number of the original data right after you sorted.
Yes. So the transaction ID, that nasty looking
Right.
GUID. Yes. Yes. So that I actually, because I ran that code in place, it is no longer here. So the only way I could get it back is to re-import the data. So
Right.
I'd have to go
Okay.
all the way, yep, all the way back to the top and re-import the data.
Yeah.
Yep. So here's the thing, case in point, if you don't want to change the original data frame, which depending on the work session that you're in, you may want to preserve the integrity of the original and just clone it as a copy so that you could always go back to the original DF in this notebook session. Then what you would do is clone it and then manipulate. So for example, if we were doing machine learning and we were doing a classification algorithm, we would definitely clone it for the purposes of creating a train and test set, because we want the original preserved. And right, so we might go in and we might split it 80-20 and decide, nope, I want to do 70-30, right? So for this simple exercise, what I did is I took a chance. But you're right, anytime you think you might want to preserve the original, remember the CSV file is intact. That does not change. It's only in this session, in this notebook. So that's the other thing to remember as well. The integrity of the original file is still preserved, and that's a really important distinction as well. All right. Okay, so the other thing we decided to do is anything that was zero. Remember those sports transactions that were zero, which we know were, well, we know why it happened, but we also know that we don't want it included. When we start doing, the data visualization, the analysis, we don't want it included. So we want to drop anything that has an amount of zero. And again, we're going to do it in place. So that's actually going to manipulate our original DF. All right, so now if I were to run this again, right? There's no zeros in here. And you'll notice I'm down to 354 rows, whereas we started out with 361. Okay, so I actually have had some data loss, reasonable relative to, what we were trying to accomplish. All right, the other thing I've decided to do is I want to convert my month column, because my month column right now is not a pure date. It is, but it isn't. It's kind of got additional data that I don't want. First of all, I want to make sure that it is in fact seeing it as a date, and I want to convert it to just the month and the year. I want to make it cleaner, right? I don't need the 2020. God knows none of us need 2020, right? But I've decided to convert the month column to a date data type to make sure it definitely is, and then convert the format. So I'm going to run this. And then I'm going to rerun this just to show you what it looks like, and voila. So I've cleaned it up a little. Okay, I've gotten rid of the day. The day doesn't really matter. It's really the month and the year that we're going to be analyzing. All right, so that's why I wanted to get rid of that. Okay, so now we get into the fun stuff. Okay, we're going to actually do some data analysis. Any questions before we actually go into our data analysis and visualization? Now, there is a whole host of things that you can do with analysis. For time's sake, I'm not going to do as much as I originally had planned. I want to get into the visualizations because that's the cool stuff. All right. First things first, having a running total is really important because our totals are going to give us information that's very valuable to us. So let's go ahead and look at a running total. All right, what does this tell us? Well, each month, right, we have a value that we've spent, our expenses, and for January, we basically spent $4,670. February, we spent an additional $4,782.50, and our running total is $9,452.50. So you can kind of see how this goes. For the whole year, our expenses was $68,000. Which may seem like a lot to folks, and it can be depending on where you're at. Now, I'm just going to open up a quick copy here and chuck this over here. One of the reasons we do running totals is you know where you started, you know where you ended, and you know what you did during the interim, right? So in looking at this interim, there's something unusual. Who knows what's unusual? Who wants to spot some unusual stuff? And I'll tell you if if what you see is what I saw when I did this. You see anything unusual? This is where you're looking for patterns. Anybody? Anybody want to take a stab?
Yeah, there's a spike in May.
In May or June? Might be hard to see. Let me jump in. Can you see it better?
Yeah, in June.
Yeah, so here we had a huge spike. So of course, inquiring minds want to know, right? What else do you see here? And you want to look at months relative to other months, normal patterns of spending.
December also.
December is a spike, absolutely. So in your mind, you might be saying, I wonder what that's about. I don't remember, right? I don't remember, having those types of things. So let's see what's going on. So let's do a visualization here, and I'm going to paste this in. All right. This is our Plotly chart. Check that out. Nice and colorful, right? A lot better than the histogram. right? You know, the other was kind of, well, plain. This gives us more information. So there's our running total. Now this is our running total. Basically, it is a visualized version, a graph version of this, right? And this kind of gives us, when we mouse over, we're able to see, okay, that was our June outlier, and here is our December outlier, right? We had a spending pattern that was, you know, a positive direction upward, which most people have that, right? We don't see anything unusual, but we do see this as being unusual, and we see this as being unusual. When we mouse over here, notice the colors correspond to what you see here, very much like a heat map. So these are consistent, these are consistent, this is an outlier, this is an outlier. So do you think this chart is a little bit more informative than the other? This is a Plotly chart, okay? Again, just a little more informative, if you will. All right. Okay, so let's put another cell. Let's insert another cell. And let's do another way of looking at things. We've identified that there is some unusual stuff going on here. Let's look at our monthly expenses. Okay. Total expenses, we still see the outlier of June. We still see an outlier of December. So our total expenses are still suspect. So remember, this is a little bit different than the running total, right? This gives us a chance to see it in tabular form, which some people like less colors and more, you know, tabular. And so, okay, let's insert another cell and let's look at the expenses over time, because sometimes visuals help us. And let's see here. Okay. So we still have this value as an outlier, and we still have this as an outlier. But in looking at this, and let's jump back here, it looks different. This was smaller than this, right? This was our running total. This is off the chain here, right? This is actually, you know, we're saying to ourselves, what the heck happened in June? Why was it so expensive? You know, what happened here? I mean, even December wasn't as bad as June. You know, in December, well, we all know what happens in December. That's holiday, right? There's always expenses that go up in holiday time. But what happened in June? So that's on our list to investigate. All right, let's put another cell underneath this guy. And actually, I'm going to put a couple cells in. Okay. So the next thing we're going to look at, and you can understand why I'm copying and pasting and not typing this, because I'm southpaw right now. I'm injured. So a lot of code to type, but this is basically the code to create this Plotly chart, if you will, and set up the x-axis, the y-axis, the title, the grouping factor. These are all things in the boot camp that I would be going over at a very granular level. Let's go ahead and run this. Here's our total expense by category for 2020. Let me zoom out just a hair. All right, hopefully you guys can still see that. So we've got loans and housing. Loans are more than housing. Now, housing makes sense. We pay that every month. You know, if it's a mortgage or a rent, you know, we know that's going to be high. But loans, what is that about? Total of $22,970 for loans. That seems a little strange to me. So that's something I definitely want to investigate. So I'm going to do that. Let's look at our description. So let's jump down, and again, we're just looking at the data in different ways. Okay. Here we've got description. Okay, mortgage is high. That we assumed would be. Look at our credit cards. That's interesting. We've got, you might not be able to see this, but our Discover card, 5,650. Our MasterCard, 4,530. Our Visa, 5,050. Dining out is 4,050. We had COVID. Dining out, well, we ordered in a lot. Not sure what happened there. Holiday Club is small. That's kind of strange. And what's this student over here? Student loan, $6,000. Okay, well, we have a kid in school, and okay, that makes sense. So looking at these, groceries is pretty reasonable. I mean, a lot of people paid extra for groceries last year because they tipped the people delivering and such. So that looks not so bad. Our vehicle payment, yeah, we have a vehicle payment, even though it never left the garage, it's still there, right? So in looking at it, we can kind of see our data a little bit differently. Let's look at loans, because loans just doesn't seem right. We're actually going to filter and assign it to a new data frame because I don't want to ruin the integrity of the original. Okay, so here we've got our DF filtered. Now I'm going to graph DF filtered. So let's put in, I'm going to put in, let's see, 1, 2, I think 4 cells here because I've got to investigate this. So let's just tuck some cells in here. All right, and one more. All right, first things first, I want to see the expenses by loan type. All right, let's see what this looks like. Okay, so we've got our credit card Discover, our MasterCard, our Visa, our personal loan, and our student loan. Wow, that's a lot of loan action. That's a lot of loan action. So now that explains why the loan category was so high, because we're including our credit cards. See, now some people, if you're purist, you might say, well, that's not really a loan, that's credit card, right? So case in point, if you categorize something and you lump it all together, you might lose that ability to really understand what's going on. Just so happened that we kind of lump things together, and sure enough, it's called a loan when it's really not a loan, it's a credit card. But now that we know that, we kind of have a sigh of relief, but we're still wondering what we were going to pay those cards down, and they seem a little high. So let's look at loan expenses over time. Let's see exactly what happened here. Okay, we're right back to this guy again. So June and December, that seems to be the area that really needs to be investigated. And again, the reason I ran that again is because sometimes you forget exactly what the outliers were. You can notate it, or you could just rerun it. So let's filter all of our rows for our loan category, assign it to a new data frame, and look at just June. I want to see exactly what happened in June. All right, there we have it. So in June, our personal loan was $145. That's not so bad. That's normal. Our student loans, okay, $500. That's about right. But we had this expense. We had $1,500, $1,500, and $1,500 split across 3 credit cards. Now, when I see that, I know that a big expense came in and we had to kind of divvy it up, right? We had to divvy it up between credit cards. And now that I'm thinking about it, I remember we had to do a repair, right? We had to do some storm damage repair. So that amount, when you add them together, that equals the amount that we had to pay out over the summer when we had some water damage. Okay, now that figure seems reasonable. The other thing that we want to look at is December, because that seemed a little odd too. Let's just make sure that it's reasonable given what we know about our finances. We're going to do the same thing. We're going to filter, and we're going to assign it to a December filtered data frame. Okay, again, we're using the date. We're looking for the literal string of 12-220 or 2020, using the category of loans, and we're going to filter it out. So sure enough, in December, personal loan, still have that expense, student loan, still have that, and we did a nice little split between the credit cards again. And sure enough, now that we're thinking about it, we bought a lot of gifts. It was the holidays. We ordered some meals in, so that can explain some of it. All right, given that it's holidays and it is the time of the year where some spending goes up, that is representative of what we remember the spending to be. Okay, so there's nothing suspect here. Okay, so what insight could we gain from all of this? Now, first things first, before I plug in the insights, you have to know your data. Now, just so happens this is a personal budget, so I have an affinity for the data. If you're doing this for a local organization or your own employer or what have you, you have to understand the problem domain. You have to understand if it's agricultural, is this representative of what I know to be true about this particular business or this particular problem in that domain? All right, so that's something really important. When you're saying I got insights, you want to factor in, what do I know about this problem domain area? Now, the insights that I gained there's actually 6 of them here. And again, as you're taking notes, you might, write them down on a piece of paper. I'm gonna number them here. And why am I doing this? Because I could actually render this in R. I'm not going to do that tonight, but I could actually create a PDF out of this whole code project that we've done and give it to an employer, give it to a client. I could actually render this code and all to someone and say, this is what we found. All right. For now, and you can see here, I made a mistake. Let's see here. Spending spiked in June and December. I have to comment this out, folks. This is not good. It's trying to compile it like code. That's not good. Well, let me fix that. At least now you can see that it'll tell you when you've got invalid syntax. And sure enough, I have invalid syntax. I like spaces, by the way. So let me do this. And let me put the 3 back in there. See, when you're doing a southpaw, let's tell it that it is not code, it's markdown. Let's execute this. And if it's too big, well, I'll explain why it's so big. All right, you see this right here? This tells it increase the size, okay? If I take that away and I rerun it, it makes it normal, okay? Markdown is very much like HTML, right? You tell it to make a header 1, header 2, header 3. So what I did is I made it too big. So let me, I don't want to shock anybody there. Let me get rid of that. Let me get rid of this. I spoke about R Markdown, by the way, and you can see that I am using Markdown based on my flipping of the cell. All right. I hate being injured. So right now, if I run this, it's going to just see it as a normal header. Okay. So what did we learn? Our spending spiked in the months of June and December. All right. The 2 highest categories of spending are loans, including credit cards, and housing, respectively. Housing includes the mortgage payment, so the total is representative of truth. And really, that's what data analytics and data analysts and scientists do. They determine what is the ground truth, and are we making conclusions based on truth. Loans included student loans, personal loans, all credit cards, so the totals are representative of the truth. To decrease monthly expenses, which is really what everyone wants to do, we focus on paying down our credit cards and our personal loans. So of course, in 2021, you might set that as a goal and then reassess next year or reassess quarterly or what have you. And then last, consider adding a fixed amount to a savings account monthly to avoid having to use credit cards for unforeseen household expenses. So as we all know, credit cards and interest and all that increases our spending. One way to fix that is to kind of tuck some savings away. All right. Some people are able to do that, some are not, but that might be a recommendation that we would make to either ourselves or our client if we were doing this analysis for a client. Okay. So questions about any of this that we did here? I hope I didn't go too fast. This was supposed to be a half an hour to 45 minutes, and I tried to talk really fast.
You did. You did too fast, but it was awesome. It was clear.
Yeah. Anyone have any questions?
Now you see what you can do. Actually,
Yes.
this was the entire purpose, because we cannot accomplish or teach you everything during this short period of time.
No, absolutely
But at
not.
least
Yeah.
it's the very welcome, very warm welcome into the data analytics,
Yeah.
and how fast and how quick and how easy to read and manage it is.
Yes. One thing to mention is that there is a traditional process. There's actually a workflow that is used. And that workflow, whether you're working as a team or as an individual, you'll follow that traditional workflow. And so what I tried to do is represent a very small scale workflow for an individual. In our boot camps, I would show you the actual, it's called CRISP DM, which is a life cycle, the data analytics life cycle that you go through. And it's repetitive, it's iterative, and it's a pattern of repetition and refinement. So for any of you that have done those types of projects, that's what you do. But one thing to remember is that all projects are going to have commonalities and differences. All right, depending on where you get the data, what the domain of knowledge is, and what have you. So I hope this has been helpful in at least giving you a glimpse, a very quick glimpse. All right.
I shared the link to the bootcamp so you can see what we will be teaching, what
Yes.
Cynthia will be teaching. You can see how powerful she is, how fast and like incredible hacker she is. She definitely can find the answers for any questions.
Hmm.
And she has multi hands on multi tools. So he will
Yes.
provide you the specific use cases which you will
Yes.
collect into the library, and this library will be very useful for you
Absolutely.
wherever you
Um,
will work.
And speaking of the boot camp, what I showed you tonight obviously is Python, but in the boot camp, I'm going to show you Python and also R, and also how to blend them together so that you can actually build dashboards that are interactive, that allows you to drill through the data and actually filter the data and query the data. And I'm also going to show you how to work with big data, large data sets. Because of COVID and other dynamics that are out there, there's massive data sets that are available for free that you can use to practice your skills on analyzing large data sets with millions of records, very rich data sets. So that's something that, and Yulia, I don't know if you want to explain how long the camp is, but there's a lot of classes back to back that,
Yeah, we were wanted to provide you with a lot of hands holding and a lot of practice just to solidify your knowledge
mhm,
while building your portfolio on GitHub and
yes,
providing the visibility for your credentials, for your resume,
yes,
and your
yes,
LinkedIn outreach as well.
yes,
So we will inject so many connections
mhm,
and career development tricks and tips and tricks for that. No
yes.
worries.
Yes. So actually what you'll be able to do is create your resume on GitHub. You'll actually have a public facing web page with your code organized by project. You can describe the project. So you know how you traditionally hand your business card to someone at a employer trade show or what have you, you could actually have your GitHub link right on your business card or in LinkedIn and point your employer to your projects and your skills, your craft. So I'm going to show you how to manage all that on GitHub, and possibly Docker if time permits.
Do you see my screen with
I
bootcamp?
do. Yes. Yes.
Very much welcome to see the link, to investigate the link. We have a lot here to share. As you can see, this is timeline to address 26 weeks, 3 hours lecture per week.
Mhm.
And we will have some quizzes, we will have labs and office time. So Cynthia
Yes.
will be available, nurturing you, babysitting you,
Yep.
hands holding you,
Yep.
just to have everything accomplished. Uh, this is very much pay as you go. So you see all these building blocks.
Mhm.
So you can take those. Heads up, it's starting very soon. So the first course is scheduled to start March 3rd.
Yeah. And we need a minimum enrollment to run it. So that's just something important too. Um, One thing I wanted to mention with the data visualization, I showed you a little bit of data visualization tonight, but there's also Power BI and Tableau, and other tools that you can utilize. Obviously Excel, you can do charts and things of that nature, but I show you how to change your visualization based on your client's needs and the options that you have. So that's a very rich,
All
rich,
right. If you want to see more about this bootcamp, here's the learning outcomes. And again, we are inviting you to the info session scheduled next Wednesday, the same
mhm,
time.
mhm,
Very much welcome. You can ask Cynthia about any kind of questions you might
mhm,
have about what's data analytics versus data science, what's the career opportunities are, what's
yeah,
the average paycheck for that, and where it's
yes,
applicable.
mhm,
Actually, even more, you will find the way how you can get your freelance gigs, helping your neighbors, helping your small businesses, your local town,
yes,
and
mhm,
your local governments.
Yep.
We will
Yeah.
show you how to use open data, which is all around us. So you will be dealing not only with your own personal data or your company data, you
Mhm.
will be dealing with the data which surrounds us. You will challenge status quo with taxes in your city, or you will find what's going on with elections,
Mm.
combining all this data, whatever you want to use.
Yes, yes. There's so many rich data sets out there, and the beauty of it is they are put out there for educational purposes and/or personal study and/or research. You know, with COVID and everything right now, there's a lot of grassroots efforts to help the local communities and things of that nature. So, data for social good. You know, I actually worked on a project recently where we the local food drives and uh, the food delivery systems for both school children and people who are stuck in the homes. I helped with some data analysis to determine how that volunteerism worked and the success of their project, and that was very rewarding. So there's a whole host of things you can do with these skills, and learning is a process. So
Awesome. Let's have like 5 minutes left out of the scheduled event for answering your questions. Anyone have any questions? And just for your comfort, I can stop recording or I can stop transitioning this to Facebook because that's what we've been doing. Then, saying that, you can rewatch this video either on Facebook or on YouTube later.
yes, yes,
Copy pasting code between you and me. But
yeah, yeah,
Cynthia will be giving all of this for free as a class materials. I mean, as soon
yes.
as you are enrolled.
Yes, all the source code, all of the data, everything. You'll have a nice package of resources available to you as a toolkit, bundled together. Also help you get your software installed and work with you one-on-one. So, you know,
But we want you to master it. So here we
yes,
are to brainstorm it as a mastermind group.
yes,
Ruben, do you have questions? Any?
No, not right now.
awesome,
But it's good to
awesome.
see you.
Yes.
Jack,
Oh,
thank you for your support. We were happy to see your supportive
yes,
smile all the way through.
yes, yes.
Thanks. This is really fun.
My pleasure.
Hi, Jack.
How you
It's
He
nice
doing?
to see your
awakes.
faces finally.
Yeah,
Woohoo.
Yeah, this
yeah.
is my work from home coronavirus end of the
Yes.
day look.
Yes, yes. After wrangling lots of data, right?
Yep.
Yeah,
Please unmute yourself, introduce yourself. 5 more minutes to
yeah.
network and brag a little bit if you want.
One other quick mention I thought I'd just
Mhm.
interject, I might not have made clear is I'll also be teaching you how to do SQL inside of Python and R. As you know, structured query language is needed to get at certain data sets. So I'll not only be showing you how to pull data using APIs in a variety of different ways. Tonight we just imported a CSV, but you might want to pull data from different ways using JSON or what have you. I'm going to show you how to query the data using SQL in line with that code. A very important skill set, and also some of the statistics, the math stuff, which some people like, some people don't, but I'm going to get you through all of that. So
That's awesome. Cynthia is real hacker, the real practitioner. And the most
yes,
important, she will make you as such because
yeah,
she will connect a lot of dots together and you will see the flow, the use cases, actually.
yes, yes.
I just love my mentors.
Yeah. Yeah.
Okay. If nobody wants to unmute themselves and just to take a minute of glory or sharing
Yeah.
any feedback.
Yeah, just not to sound like a poster boy or anything. I enrolled, for those of you that are on the fence or haven't enrolled or you're hearing about Open Hub projects for the first time. I took the web development boot camp last year, and it's I would have to say it was rewarding. It was productive. It's way better than going on things like Udemy or Coursera. Not that those aren't bad. You know, they have their merits as well, but it was just rewarding to be able to have you know, a small class environment through Zoom with the instructor and have class after hours time as well. So
Right.
yeah, I highly recommend it.
Thank you, Jack.
Yes,
Being
very
part of
much.
this supportive environment, being
Mhm.
inside the supportive environment, that's what we will be practicing. That's for sure.
Absolutely.
Thank you, Jack.
Yeah.
And I wasn't paid to say that.
Oh.
Yeah. Wonderful. Wonderful.
Mm.
Thank you, Jack.
You got it.